Okay, so today in this video, we are going to just write a program that takes a number and finds its factors. That's step one towards some of the project roller problems we'll do in a little while that involve figuring out the factors of numbers or finding the largest factor of a number or whatever. Um, and then the thing we want to do after that is take all those factors and put them into some kind of list. Those of you who know Python know how lists work in Python. It's a little bit different in Java, so I haven't figured out if I'm going to do both those things in this first video. I might just do the regular factoring in one video and the list in another video. We'll see how long this takes. So the first thing I need to do is I'm going to import the scanner package because I'm going to need to ask the user for a number to factor. And then I've got my sort of Java plumbing here. I've got my public class, and then the name of my program. Sometimes I just leave this main. Today I've called it factoring. Just keep in mind, if you change the name of your main class, excuse me, you have to change the name of the corresponding program name in your Java sidebar here, which is the actual file that holds your program, has to have the same name as your main class in Java. So if you change this to anything other than main.java, which is the default name that it gives it in CodeHS, you have to change the name in both places. So I'm calling my program factoring, and this is my start of my main method. And here I'm just going to prompt the user for a number. I'm going to do some copying and pasting here so you guys don't have to sit through me typing all the time. And let me tidy up my tabs here a little bit. Okay, so system out print line, I'm having the program just say, you give me an integer and I will calculate all of its factors. And then we're going to need to read some information in from the console. So we need to create some kind of object of the scanner class to do that reading for us. And the way we do that, we've done this before, is scanner. Before we called this input, I think. You can call it whatever you want. So I'm calling my scanner, which is maybe a little confusing, but you're allowed to do that. So I'm creating a new scanner object called scanner, and it's going to be where I get my system input. That's the argument of that function. Again, we don't know all of these, all the ins and outs of this object-based stuff right now. For now, this is just syntax that we're going to go ahead and memorize. So this creates my scanner object for reading in text. And then I'm going to, let me give myself a little bit more room here. Then I need to prompt the user. Well, we need to prompt the user for some input. So I'll have a print statement. System out print, please enter a number for me to find its factors. Really, really straightforward. Now I need to read in something from the console that I'm going to factor. I'll call that thing I'm going to factor my number. Okay. My number that I'm going to factor is going to be an integer. So I need to declare it as a type of int. And then that's going to be the next integer that I read from the scanner. So my number is equal to scanner dot next with a capital I int. Okay, so this will read the next integer typed into the console. So we're reading a number in, and then we're going to factor it. How do you factor something? You just, the most brute force way to factor something is to try to divide it by 2, try to divide it by 3, try to divide it by 4, and see if the modulo is equal to 0, see if it divides with no remainder. So I'll create a integer called test factor, the thing I'm going to try to divide it by, and I'll initialize it with a value of 2. I'm going to start dividing with 2. Okay, so we initialize the test factor variable. And then I'm going to need a for loop that goes through and tests from 2 up to half of my number. Again, when you're factoring something, you don't have to go more than half the number to see if I find any factors. So do I need a for loop or do I need a while loop? I could do it with a for loop. but I think the way I have it written originally is with a while loop. So let's just do it with a while loop. While test factor is less than. Now, how high do we want to go? It depends how we want to do this. When we find a factor, we could just say then my number is 10, right? And I'm going to divide it by 2. Okay. I could just, well, say my number is 10. I'm going to try to find its factors. I start by dividing by 2. 2 divides evenly, so I know it's a factor. The thing that it divides evenly with is 5, and so 5 is also a factor. So I could just go up to half my number and just take both of the factors. Or I could just go all the way up to the number and keep all the factors. Because of what I'm going to do later, which is put them in a list, let's just go all the way up to my number. So we're not going to stop at the halfway point because we're going to get all of the factors one at a time. It's a little bit clumsy way to do it, but hopefully it'll be obvious why we do that later. And then I need my open and close curly braces. Notice that in this program, I'm using the convention of putting the opening curly brace on the same line as the loop or whatever starts the block. Here I've put that opening curly brace on the same line as the class definition. Here I put it on the same line as the main method declaration. Here I put it on the same line as the while loop. That's pretty common. I tend to not do it that way when I'm programming for myself. I tend to put it on the next line, but it's a little more compact to put it on the same line. So you can do it either way you want. These should actually probably be indented too. Remember, indentation doesn't really matter in Java, but it helps you follow your code. So I'm going to try to indent a little more nicely. So while test factor is less than my number, we don't have to go all the way up to my number because everything's divisible by itself. I'm going to try to divide it. So if my number, that's the number we're testing, modulo test factor is equal to 0, and then I guess I'll need another curly brace to go with my if statement. And again, you probably wouldn't comment this aggressively if you were commenting for yourself, but I'm being a little overly verbose with my comments. So what are we going to do if we find a factor? Let's just print to the console that I found one. So system.out.print test factor is a factor of my number. Okay. And again, I'm copying and pasting just to make this a little faster. I know it's not exciting to watch somebody type and make a lot of mistakes. Okay. So every time I find a factor, I print so-and-so is a factor of my number. Then my while loop ends, and then I think I'm done. Okay, so let's go ahead and run it and see what we get. Let's pick a number that has lots of factors. Let's pick 60. Uh-oh. 2 is a factor of 60, 2 is a factor of 60. It keeps going over and over and over again. Why? Because I forgot to increment. I forgot I was using a while loop instead of a for loop. I forgot to go to the next factor. So test factor plus plus. Okay. When you're using a while loop, it does not automatically increment the number the way it does in a for loop. So increment test factor by 1. That should be a semicolon. Let's try that again. 60. There we go. So there are the factors of 60. 2 and 3 and 4 and 5 and 6 and 10 and 12 and 15 and 20 and 30 are all factors of 60. It's a little bit clumsy because we are taking 60 and dividing by 2 and finding it's divisible. What's 2 divided by 60? It's 30. Rather than just saying 2 and 30 are factors of 60, we go all the way up and we check all the numbers all the way up through 30. We could make this faster. We could make it more efficient. But I don't think I want to just yet. Because what I want to do to all these numbers is add them to a list. And so I'm doing it a little brute force. In fact, it might actually be a good homework assignment to ask you to make this more efficient by only going up to half of my number and keeping both of the factors and putting them both where we want them. So that number does, that program does what we want it to do. It's a little bit, there's one thing I don't like about it, which is this. Let's run it again. Come on. Sometimes we gotta wait for code HS to let us in. You ready? Okay. Nope, I'm getting the blinking light from code HS. There we go. Please enter a number for me to find its factors. Suppose I enter 23. The program doesn't do anything. It just stops. And the reason it stops is because 23 doesn't have any factors, and we don't have the program do anything if it doesn't find any factors. So one thing we might want to do is to create, at the same time we create the myNumber variable, create a Boolean called isItPrime. Did a terrible job of trying to spell that. isItPrime. Set it equal to true at the beginning, and when I find a factor right here, if I found a factor, if my number dot modulo test factor is 0, then isItPrime is false. So when I find a factor, I set that Boolean equal to false. And then at the very end, when we're all done, after our while loop, we can have a statement that says, if isItPrime is true, if I went through all that and I didn't find any factors, then print a little thing that says, my number has no factors, it is prime, exclamation point, end quote, end curly brace. Oh, end parentheses, end curly brace. And I'm going to need a semicolon in there. Let's run that. Uh-oh. Variable. Oh, isItPrime did not have a capital in it when I retyped it. Small errors, typing errors, no big deal. So enter a number to find its factors, 31. 31 has no factors, it is prime. So that's just a fail-safe, so we don't have a program that does nothing under a certain condition. You always want to make sure that your programs can handle unexpected situations, or can handle all the situations that it might encounter. So a possible situation is a number with no factors, and now we have a little fail-safe in there that if we don't find any factors, if we go through all the checking and we still have no factors, then we go ahead and print out at the end. It's a prime number, so the program doesn't just stop and give us nothing. Okay? So that is that. That was pretty fast. So let me, let's go ahead and do it with a list. Hold on 1 second. I got to go down here for a second. Those of you who have had physics here in the physics lab in 301 in McNair Hall know how cold it can get in here. So I've got a little space heater down on the floor, and it's literally setting my pants leg on fire, so I had to turn it off. It's too much. All right, so the first thing we have to do is remind ourselves of the data structure in Python called a list. A list was built into Python. We could take a whole bunch of terms and put them in a list. We can add them and put as many as we want in that list. We could just append them to the list as we go. In Java, there's something called an array. An array is really, really similar to a list, but an array is fixed in size. Once you create an array, you can't make it bigger. sort of the way strings were in Python. You remember in Python, strings were immutable. You couldn't take a string and change its individual letters or append letters to it easily. And arrays in Java are immutable. But there is something else called an array list in Java, and we're going to use those today. It's a little backwards to skip arrays and go to array lists first. But the reason that we're doing it that way is because most of us in this class learned a more modern language than Java first. We learned Python. So an array list in Java is most like a list in Python. So that's what we're going to start with. Except that array lists are not part of the standard Java package. You need to import it. So what I'm going to do over here is copy what we need to import that. Here, when I import my scanner package, I'm also going to import java.utility.ArrayList, and that allows me to use ArrayLists in my program. I can't use them if I don't do that. And the other thing I'm going to do is I'm going to keep this program as it is. And I'm going to write the program all over again. Do it all over again with an array list. So we can jump up and down and compare the two with one another. Just copy and paste things. And so you guys will have all of this code in a single file. And I just realized that I didn't mean to overwrite my original code. I guess I'll fix it later. So what are we going to do? We're going to prompt the user for input. We're going to read that input. We're going to do all the same stuff we did before. So I'm just going to paste the code from before. Write to the console, give me an integer. I don't know why it says that twice. Okay, you give me an integer and I will calculate all of its factors. And then my number equals scanner.nextInt test factor equals 2, true. Sorry, test factor equals 2, is it prime equals true. We started out just like before. But now we're going to create an array list. And this is what that looks like. It's a lot. It's just like even creating a scanner is a lot of code in Java. It's a lot of code to do this. Okay, it's array list and then angle brackets, integer. That tells it that I want to create an array of integers. You have to tell it what you're going to make an array of. Then you give it a name. The name I'm giving it is FactorList. And that's going to be a new object of class ArrayList. And then the little greater than or less than angle brackets. And then a parentheses. That is a lot of code just to create a list. It's not my fault, guys. It's Java's fault. So this creates an array list called FactorList. And it creates it empty. I could put things in here to put it in the array list when I initialize it, but I'm creating an empty array list. Maybe I should write that explicitly. Creates an empty array list called FactorList. Okay? I haven't populated it with anything. I've just created it. Called FactorList, capital L. Okay. And then I'm just going to copy all my code from before. While test factor is less than my number, blah, 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 find factors. All of it's the same. I'm just going to add one thing to the middle. Okay. So while test factor is less than my number, if my number mod test factor is equal to 0, if it's divisible, print out that the factor is a factor of my number. Set is it prime equal to false. But now I'm going to add one more thing. In fact, instead of printing it out, I'm just going to add the current test factor to factor list, this array list that I just created. And the syntax for that method, okay, the add method, adds the thing in parentheses to the array list. Okay, so that is equivalent to, in Python, what would have been the append method. Okay, in Python, you appended something to a list. In Java, you add something to factor list, and I should add it to the end of that list. So I find a factor, I add it to the list, I say is it prime equals false, and then I increment my test factor, I end my while loop, and when I'm done, I print the factors are whatever. Okay, and I can put, or I'm going to try to put and see how this works, I put the whole array list in my print statement. So system.out println the factors are, and then factor list. Does that work? I'm going to put a comment that says, what will this do? What will that look like? I know in Python I could print a whole list, right? What can I do that in Java? Let's see. Run. Let me give myself a little room in console here. Uh-oh, all kinds of errors. What am I missing? Probably lots of look at all these errors. Error class line 50. Looks fine to me. Maybe the line before. Oh, is it this? I think that when I added stuff in the middle of the program, I forgot to delete the curly brackets that ended the program before. I think I just pasted it in the wrong place. Those curly brackets go down here. That's why I always comment these things. And it seems silly. But I was trying to put code in after the end of the program. Now I've just got a simple error. Variable is it prime, again, it's got a capital in it when it shouldn't. That's line 54. Is it prime should be a lowercase. Run. Okay, so let me, just because I was kind of doing this on my own, when I put in extra code, I put it in after the curly brace that ends the main method, and after the curly brace that ends my class. And that's not okay. You can't put code in after you've ended your code, so that was just a silly mistake on my part. All right, so we look good over here. Let me move my console window a little bit so we can see a little better. Please enter a number. That's a little bit, that statement wound up awkward. Let me type in 60. Okay, so 2, 3, 4, 5, 6, 10, 12, are factors of 60. And then the second half of the program where we just have it do it again and put them in a list. So 60. And look at that. The factors are 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. So it puts them in a list and just puts them in brackets, which is what we use to designate the objects in a list in Python and an array list in Java. So that works. We could clean this up a little bit. I would like a space there. I would like my documentation for the second half to say, now give me an integer, and I will calculate all of its factors and put them in a list for you. Exclamation point. And then a space. Just clean up my user interaction a little bit. Okay, so we do it the way we did it first, where it just prints them all out, and then we do it again, where it takes them and it puts them in a list: 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. And we could modify this program so it included 1 in the number itself. What happens if I run it and give it a prime? Let's do 31. We know what it does in the first one. It says 31 has no factors. It is prime. Okay. If I do it in the second one with the list, okay, it says the factors are, and then the empty set, and then 31 has no factors. It is prime. We could, maybe we don't like that. Maybe we don't want it to print the factors if it doesn't have any. So we could put this in a if is it prime equals false. Do this. Copy all that. Put it in the curly brackets. Okay, notice a couple of times here I've done this thing where I put it all on one line. Right? I take all of the stuff that's happening if this if statement is true, if is it prime is false, do the stuff in the curly braces, and I just put that all on the same line. If you've only got one command that you're executing for an if, that's an okay way to do it. It puts that all together, and you can look at that one line and kind of process it all with your eyeball, rather than this tab return. Like, that's a lot for just one line of code, right? So if you've only got one statement being executed as part of an if, it's not uncommon to either put it all together on one line like that, or put it all on the same line of code. Another thing that I will sometimes do is line up, because true and false have different numbers of letters. Okay, if I just put one space after these wouldn't line up. Sometimes I'll just put in extra spaces to make stuff line up nicely. Java doesn't care about that, so it does care about weird periods that I typed that don't belong there, but it doesn't care about that extra space. So let me just go ahead and run this. CodeHS is being a little slow today. Okay, so let's do a bigger number. 360 has lots of factors. Okay, 2, 3, 4, 5, 6, 8, 9, 10, 12, blah, 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 blah. All the factors of 360. Now it asks for them again, so we can put them in a list. Okay, the factors are, oh, you can't see that because it's behind my head. I can't type in the console unless it's asking me for something. Let me see if I can move my head somewhere different. Up here. The factors are 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 360 is divisible by all of these things. That's why there are 360 degrees in a circle. Most of you have heard me tell that little story before about the Babylonians. Yeah, so that's an array list. So far, all we know how to do with an array list is create it, put stuff in it. What we'll look at in a later program is how to address and pick items out of it, and how to iterate through an array list as we go. One of the reasons for doing this now is because I want to do some prime number programs where I don't just take a number and say, is this prime, is this prime, is this prime, is this prime, but find all the prime numbers and put them in a list so that I have them to go back to and don't have to recalculate them every time I want to figure out if something is prime. So that is what we'll do in a later program.